Good morning. It is Wednesday, April 29th, and today we will write the equation of sinusoidal functions using amp sine freq x shift. Midline equals min plus max over 2, and frequency equals 2 pi over period. So what we've been doing is we've been graphing given the equation. Today we're going to be given the equation. Today we're going to be given the graph, and we're going to write the equation based on that. So we need to know our four waves. Positive sign starts at the midline, goes up. Negative sign starts at the midline, goes down. Positive cosine starts at the max. Negative cosine starts at the min. Hopefully at this point you're comfortable with those waves. We have some steps that we're going to follow. It's very similar to what we did in the other direction, but slightly different. There's this one new little formula. The midline is going to be the min plus max over 2 to find the midline. Other than that, it's really the same type of thing that we're doing. And we'll refer to these steps as we go through some examples. So let's take a look at our first example. The accompanying graph represents a portion of a sound wave. Which equation best represents this graph? Well, start with the midline. Step 1, I want to find the midline. Because once I have the midline, it's going to be very clear to see what type of wave it is, what the amplitude is. Everything comes from the midline. So the midline is the min plus max over 2. So we're going to start with that. So the min is 1, and the max is 3. 1 plus 3 is 4 over 2, which is 2. So I want you to draw in the midline. In fact, I wouldn't really draw in the min and the max. I just kind of did that so you could see it. But it can get a little confusing with so much stuff there. Now, some of you might be saying, I could see that the midline was 2 without doing that little formula. Great, but there's definitely going to be examples where it's not going to be as obvious. That's why we want to get comfortable with the formula min plus max over 2. So again, to get the midline, take the minimum value, take the maximum value, add them and divide by 2. Basically, you're taking the average of the min and the max. That's what the midline is. Now that we have that, amp sine freq x shift. What's the amp? Well, the amp is the distance from the midline to the max or the min. So the distance from the midline to the max is 1 in this example. Is it sine or cosine, positive or negative? Well, look where it starts on the y-axis. It starts at the midline and goes up. When you start at the midline and go up, that is positive sine. So it's a positive sine. Freq. Well, frequency is 2 pi over the period. So what's the period? Well, this is important. The period is the wavelength. It's where one full wave ends. One full wave ends there at pi. So the period is pi because the full wave ended at pi. So it's 2 pi over pi, which is 2. And then my shift is my midline, which again is 2. Now that I have that information, I'm just going to substitute it into amp sine freq x shift. Amp sine freq x shift. Y equals the amp we said is 1. Positive sine. The freq is 2. X, the shift is 2. 1 sine 2x plus 2. That is choice 4. That's all there is to it. You're just basically following these steps, and it's all about the midline. If you don't have the midline, it's going to be a lot harder to find the amplitude, determine if it's sine or cosine. So it's really important that we get the midline. Let's take a look at number 2. Just want to blow this graph up a little bit. Much better. Let's go with my favorite color, purple. Again, start with the midline. The midline is the min plus the max over 2. So the midline is -2 plus +2 over 2, which is 0 over 2, which is 0. So my midline is 0. I draw it in. Again, for this example, you might say, yeah, I knew it was 0 just by looking at it. Great. Once I have my midline, I'm going to start looking at amp sine freq x shift. Amp sine freq x shift. Amp is the distance from the midline to the max or the min. That's 2. Sine or cosine, positive or negative. Look where it starts. It starts at the min, so it's got to be a negative cosine. Freq is 2 pi over the period. So be careful here. The period is not where the graph ends, it's where one full wave ends. Well, this is a negative cosine. So let's look at negative cosine. Negative cosine starts at the bottom, goes middle, top, middle, bottom. It completes one full wave once it gets from the bottom back to the bottom. So what's the period of this graph? It's back at the bottom. There's bottom, middle, top, middle, bottom. This is the end of one full wave. The period is pi. It's how long it takes to make one full cycle. That's what period is. So they're showing 2 cycles here. That's great and all, but the period is where one cycle ends. Think of it this way. The period is pi, so it's going to take pi to make one wave. It's going to take pi to make the next wave. That's why the next wave is 2 pi, because from pi to 2 pi is pi. If that makes sense, great. If not, don't worry about it. So either way, the period is pi, so the frequency is 2 pi over the period. The frequency is 2. Shift, the midline is 0. Again, if you still don't understand, the midline is the shift. So, y equals amp sine or cosine, negative cosine, so the negative goes in front. Freq x shift is 0. You don't have to put the plus 0. We can clean it up. -2 cosine 2x. And that's it. Guess we could take a look at number 3. 3's got a little twist to it. Again, I'm going to start with my midline. Mid equals min plus max over 2. My min is -1. My max is 1. My midline is 0. Amp sine freq x shift. Amp is the distance from the midline to the max or the min. That's 1. Sine or cosine, positive or negative, it's starting at the max. That's positive cosine. The frequency is 2 pi over the period. So I need to find the period. Here's a little twist. Period is how long it takes to make one full wave. I don't see a full wave. I see half of a wave. So you have to use your brain a little bit here. If it's half of a wave to pi, then the other half will be double that, which is 2 pi. Hopefully that makes sense. Again, if it's half of a wave to get to pi, double that, 2 pi would be a full wave. So it's 2 pi over 2 pi, which is 1. My shift is 0. So, amp sine freq x shift, amp, positive cosine, freq x shift. I can clean that up, and that's just a regular cosine. Choice 1. All right. Let's skip ahead a little bit. Let's try number 10. And I think it's going to be the last one that we do. So, I need to always start with the midline. The midline is the min plus max over 2. So, the min is 2. The max is 8. 2 plus 8 over 2 is 10 over 2, which is 5. Draw it in. Always draw in your midline. All right, so now it's amp sine freq x shift time. Amp sine freq x shift. The amp is the distance from the midline to the max or min. The distance from 5 to 8 is 3. Is it sine or cosine, positive or negative? It's starting at the min, so it's negative cosine. Frequency is 2 pi over the period. So the period is how long it takes to complete one full cycle. Well, this is one full cycle. The period is 30. So the frequency is 2 pi over 30. Now all I can do is reduce that. 2 over 30 becomes 1 over 15. So I get pi over 15. So that's the only thing different for this example. Your period's not going to always have a pi. It could, in fact, in real life, you're not going to have a pi. You're generally going to have numbers. If I'm talking about, like, a Ferris wheel going in a circle, it doesn't take 2 pi minutes. It takes 2 minutes. So it's very normal for the period to be an integer and the frequency to have a pi in it. Shift is the midline, which again is 5. I want to give you 30 seconds now to try and put that all together and come up with your answer. Okay. Amp is 3. Sine or cosine, negative cosine, negative goes in front. Freq x shift. It's got to be negative, so it can't be those. There's your answer, choice 4. So as long as you follow this procedure, you will come up with the answer every time. Try to see if there's any other little twists that it needs to really talk about. 12 was a little tricky, but yeah, let's take a quick look at number 12. In fact, let's have you take a look at number 12. I'll give you about a minute and a half to take a look at it on your own. As a hint, this is a good example to get just by kind of eliminating wrong choices. It might help you see more clearly what's going on, but again, I'm going to give you about a minute to a minute and a half to try number 12 on your own. Okay. And again, I think the best way to get this answer is to eliminate wrong choices. Let's start with the fact that it's a cosine function. It doesn't say if it's positive or negative, so cosine is going to either start at the max or it's going to start at the min. So choice 1 is a positive cosine. Choice 2 starts at the midline. That's a sine function, it can't be that. Choice 3 starts at the min, that's a negative cosine. Choice 4 starts at the midline, that's a negative sine. So I'm already down to choices 1 and 3. Amplitude of 2, well, I can kind of just see the midline for each of them is at 0. They both have an amplitude of 2. So that one checks out. A period of 2 pi over 3. That means one full wave will end at 2 pi over 3. Well, it definitely can't be choice 1, because here's 2 pi over 3. Is this one full wave? No, this is like 1, 2, almost 3 full waves. So that definitely does not have a period of 2 pi over 3. So this one's out. So it can't be this one, it can't be this one, it can't be this one. We have our answer. Now, I don't see 2 pi over 3, but I know my period is going to be here. Now, there's two ways of looking at this. If there are 3 waves to 2 pi, then I would do 2 pi over 3 to find each wavelength. And there you go. Or you can look at it from a frequency standpoint. Period is 2 pi over the frequency, which means the frequency is 3. Frequency, by definition, is how many full waves you see between 0 and 2 pi. How many full waves do I see between 0 and 2 pi? I see 1, 2, 3. Either way, that's your answer. So this is a very important lesson. Every Regents asks this question. Follow your steps. You're going to start by finding your midline, which is the min plus max over 2. It's essentially the average of the function. We're going to get the period. We're going to use frequency equals 2 pi over the period to find the frequency. Once I have all that information, I'm going to substitute my values into amp sine freq shift, and I'm done. Your classwork / homework. Let's just come back to the main thing here. Your classwork / homework is to finish writing the equation of sinusoidal functions. Your quiz is going to be due on Friday. Even though it's a 2-day lesson, you should get it done today or tomorrow. And then we're going to utilize everything we've done so far with modeling on Friday. We're going to spend a while on that. So again, I can write the equation using amp sine freq shift. Midline equals min plus max over 2, and frequency equals 2 pi over the period. Very similar to what we've been doing for the past week. Now we're just going the opposite direction, so the main new stuff is right here. You're going to have to start with the midline, which is min plus max over 2, and the frequency, which is 2 pi over the period, just like period is 2 pi over the frequency. Have a great day. Reach out to me and remind if you have any questions. And that's all I got.